Today's topic, we're going to talk about solving inequalities using addition and subtraction. So you might ask yourself, what is an inequality? An inequality is a mathematical sentence formed by placing one of these symbols, less than or equal to, greater than, or greater than or equal, between two expressions. So it's just like an equation. Maybe if you have an equation that looks like 2x equal 4, except now instead of having an equal sign, we're going to replace the equal sign with one of these symbols, either a less than or equal, greater than or equal. So let's talk about the different symbols that they have. This symbol, greater than, means greater than, more than, exceeds, in excess of. The symbol greater than or equal, notice they have an equal sign underneath it, so it means it could be greater than or it could be equal to. Greater than or equal to, no less than, at least. This sign here is less than, which means less than, fewer than, or up to. And this sign here is less than or equal to, which means less than or equal to, no more than, at most. So all these inequalities represent a set of solutions. Typically when we solve equations such as maybe we have 2x equal 4, we would divide by 2 on both sides and we end up with one answer, which is x equal 2. Now instead of having just one solution, x equal 2, we have multiple solutions for these inequalities. X greater than 5. It means that any value x, which is more than 5, satisfies the equation, or satisfies the inequality. So numbers that work for x greater than 5 would be 6, 7, 8, 9, 10, so on and so forth, and it goes on forever. X greater than or equal to 12 means the numbers that work for this have to be greater than or equal to 12. So the numbers that work, you could have 12 because it can be equal, 13, 14, so on and so forth. The numbers that work for x less than negative 3 means there are numbers that are less than negative 3. So they can't equal negative 3. So all the solutions are going to be like negative 4, negative 5, negative 6, so on and so forth. And then down here, x less than or equal to 7. If x is less than or equal to 7, it's going down from 7. So 7, 6, 5, 4. And remember, it can be 7 because it could be equal. But the numbers have to be less than or equal to 7. It's actually easier to see this if you go ahead and graph an inequality. So what does a graph of an inequality look like? On a number line, the graph of an inequality in one variable is a set of points that represent all solutions of the inequality. So what we're going to do is we're going to graph each of these on a number line. So if I make the number line here, it says x is greater than 5. Well, for x is greater than 5, let's go ahead and mark 5, 6, 7, 8, and it says x is greater than, so it means that it cannot be 5. So whenever something can't be 5, you're going to represent that with an open dot. And it says x is greater than 5, so you're going to draw a line representing that this x is greater than 5. This open circle with the line represents all the solutions for this inequality x greater than 5. For x greater than or equal to 12, now you draw the number line, mark it 12, 13, 14, 15, you might even say 11, 10, but this time it can be equal. So instead of using an open dot, we're going to close the dot on 12, and it says greater than or equal to 12, and then we're going to draw our line going that direction. This is x greater than or equal to 12. Okay, it can equal 12, so we fill in the dot. For x less than negative 3, we're going to mark the number line. And we're going to say negative 3, negative 4, negative 5. On this side, negative 2, negative 1, 0. It does not say equals. It says x less than negative 3, so we're going to use an open dot for this to represent that it cannot be negative 3. And then we're going to mark x is less than negative 3. And finally, x is less than or equal to 7. We're going to mark the number line. 7, 8, 9, 10, 6, 5, 4. Because it's less than or equal to, it could be equal, so we're going to put a closed dot on 7, and then less than or equal, draw my arrow back to the left. So these are what inequalities are. These are the symbols for the inequalities. And this is what the graphs on a number line for inequalities look like. Now we're going to solve one variable inequalities using addition. I have 4 steps here that you're going to use to solve these equations. The first step is going to be get the variable by itself. That hasn't changed since solving equations or solving inequalities. We're going to always get the variable by itself. But then we have 3 things that we have to do after we get the variable by itself. We have to write the corresponding interval notation. We have to graph it on a number line. And then we need to graph it on the coordinate plane. So we have 3 different things we have to do. Technically, they're all doing the same thing. They are showing the solutions to the inequality. So first, solve the following inequality. It says some number minus 10 has to be less than 12. So if I want to solve this, I'm going to do the inverse operation and add 10 just like we would if we solve an equation. Nothing changes. The only thing different is this instead of an equal sign. So x has to be less than 22. So that's step 1 right there. Okay, step 2 is to graph it on a number line. Or no, step 2 is to write the corresponding interval notation. So there are 2 different symbols that you're going to use. You're going to use a bracket. A bracket means that it can be equal to that number. So bracket is can be equal. And a parenthesis is not equal. So when I go to write this interval notation, my interval, I'm going from 22, okay, or x is less than 22, so I'm starting at 22, so I'm going to say 22. It cannot be equal, so I'm going to use a bracket. So I'm going the range of solutions that I have are anything less than 22, so all the numbers that are less than 22 are 21, 20, 19, 18, 17, 16, so on and so forth, all the way till really infinity, but not positive infinity, being negative infinity. So my interval for this is 22 to negative infinity. And because we can't ever reach infinity, I'm going to use a bracket for that as well. So this is interval notation here. 22 to negative infinity. Part 3, graph on a number line. So just like I showed in the previous video, we're going to make a number line. We're going to mark 22. Okay, I'm going to mark a couple other ones, 21, 20, 23, 24. And remember, when you're on a number line, open dot means can't equal. And closed dot means that they're equal. So, in this situation we have x less than 22, so it cannot equal, so open dot, and we're going to mark it to the left. And finally, part 4, I'm going to graph this on a number line. Or sorry, I'm going to graph this on the coordinate plane. So if I want to graph this on the coordinate plane, I'm just going to draw a graph. It says x less than 22. So I'm going to go up by tens. This is 10, this is 20, this is 30. And if you remember from when we graphed equations before, anytime I have x equal 22 or x by itself with no y in the equation, I get a vertical line. So I'm going to have a vertical line at 22, which is right there. Now, when you're graphing on the coordinate plane, just like the 0 and the open dot can't equal and the closed dot does equal, dashed lines mean they can't equal, and bold lines mean it does equal. So, because I can't equal 22, I'm going to make a dashed line there at 22. And because it says x is less than 22, less than, well, all the numbers that are less than 22 are to the left, so I'm going to shade toward the left. So all these numbers to the left. Now let's look at example 2. We're going to add 4 to both sides to solve this problem. So we get x less than or equal to negative 7 plus 4 is negative 3. So that's step 1. Get the variable by itself. Step 2, I'm going to write the corresponding interval. So what's the corresponding interval for this? Well, if I use interval notation, it says x is less than or equal to negative 3. So I'm going to write negative 3 first. Less than or equal to means I'm going to use a bracket because it can be equal. And if it says less than, that means I'm going to be going towards, well, more negative numbers. And it's going to be like negative 4, negative 5, and negative 6, negative 7. But it goes on forever until infinity. So I'm going to write negative 3 to negative infinity. And because I can never reach negative infinity, I put a bracket there. Or a parenthesis there. So bracket if it can equal, parenthesis if it can't. Number 3. I need to graph it on a number line. So I draw the number line. I'm going to mark negative 3. I'm going to mark other numbers next to it, so negative 4, negative 5, negative 2, negative 1. It says negative 3 to negative infinity. I'm going x is less than or equal to negative 3. So I'm going x is less than or equal to negative 3. So because it can be equal, I'm going to use a closed dot. And it's less than negative 3, so I have to go toward the more negative numbers. So I graphed it on the number line. And then finally, I'm going to graph using the coordinate plane. So I draw the coordinate plane. It says x less than or equal to negative 3, so I'm going to write negative 1, negative 2, negative 3. And again, it can be equal this time, so I can use a bold vertical line, and it says it has to be less than or equal to negative 3, so I'm going to shade toward the more negative side. Alright, now we're rolling, so I'm going to do the same thing, except now I'm going to use subtraction instead of addition. So the same steps apply. Step 1, I'm going to get the variable by itself, so x is greater than negative 6, minus 2 on each side. That's step 1. Step 2, I'm going to write the corresponding interval notation. So remember, interval notation, if you have a bracket, means it can be equal. If you have a parenthesis, it means it cannot equal. Okay, can be equal, cannot equal. So if I go ahead and mark this x greater than negative 6, well, negative 6 is the first number. It's greater than, but it does not say equal, so I use a parenthesis. Negative 6 to, well, if I'm greater than, I'm going like negative 5, negative 4, maybe 100, a million, so on and so forth till I get to an infinite amount of numbers. And because you can never reach infinity, use a parenthesis there as well. For number 3, I'm going to graph it on a number line. So draw the number line. Mark -6, -7, -8, -5, -4. It can't be equal, so remember, on a number line, an open dot cannot equal, but a closed dot does equal. So open dot, -6, mark that there because it can't equal, and then because it's greater than, x greater than, I'm going to mark that direction. And then finally I'm going to graph it on a coordinate plane. So I go ahead and mark, or make a coordinate plane. So I go ahead and make a coordinate plane. It's x greater than -6, so I'm going to mark -1, -2, -3, -4, -5, -6. And if you remember, bold lines if they're equal, dashed lines if they're not equal. So -6, I'm going to make a dashed line at -6. And because it's greater than, well, the numbers that are greater than -6 are this direction, so I'm going to shade this direction. Now let's take a look at example 4. It says solve the following inequality. I'm going to subtract 5 on each side. So step 1, get the variable by itself. That gives you x greater than 12. Ooh, greater than or equal, so greater than or equal to 12. That's step 1. Step 2, write the corresponding interval. Well, greater than or equal means that one thing can be equal. So 12, we could be equal to 12, so we're going to mark a bracket there. This thing is going from 12 to, well, greater than means I'm going up as high as I can, or I could have any numbers after 12, so on and so forth until I get to a positive infinity, which we can never reach, so we put a parenthesis there. So that's the interval notation. Part 3, graph it on a number line. So I'm going to mark the number line, 12, 13, 14, 11, 10. And then because I can equal 12, x is greater than or equal to 12, I'm going to use a closed dot. Greater than means I'm going to mark it to the numbers that are greater than. Well, 13 and 14 are both greater than, so I mark it that direction. And then finally in number 4, I'm going to make the coordinate plane. It says greater than 12, so I'm going to go up by 5. So 5, 10, 15. So 12 is right in here. And because I am greater than or equal, I'm going to use a bold line. And greater numbers that are greater than 12, go this direction toward the 15. So I'll mark it this direction, shade it that direction. So all these in here are solutions. Any point that's on this side of the line are solutions. Any point that are on this side of the line are solutions. Don't forget to do the you try problems.